Hello everyone, I'm Teacher Akin. Today we are going to have a look at Gigo product 7412, a robotic smart machine, track and TREADS. This set is focused on models and vehicles that use tracks. You can connect your mobile phone to your devices and models, and you'll be able to control the model remotely, or even make programming changes. Okay, now let's take a look at some information from the box. First, you can see that there is an A+ symbol in the lower left-hand corner. This means it is more suitable for children 8 years and older. The reason for this is because some of the programs and models are a bit complex for younger players. It is really not recommended for children under 8. We can see here where it says 197 pieces. This means there are 197 components in the set. So we suggest that when you open the box up, you break out the manual and run a quick inventory of the piece. Now, looking in the lower right hand corner, this number 8 means that there are 8 models that we can make from the instructions. All the models are included in the manual. Of course, it's fine if you want to make your own models. In fact, it's great. Over here, there is a QR code. If you scan this QR code using your phone, it will direct you to Gigo's official website. There you will be able to see all the models and some related videos. Now, let's see some of the components you'll find inside. There's the manual, and there's the components from the C series. Inside there are 4 packages. Some have tires, some have small components. Others have tracks. Let's look more closely at some of the more fundamental components. These are the sensors and the 2 planetary motors we mentioned. In this part, here's your Bluetooth receiver. With this receiver, you can connect your phone to the device. I have 3 alkaline batteries ready here. We'll be using alkaline batteries because we want to ensure the device is working optimally. Now, let's run a quick test on your sensors and planetary motors. In order to control them, we first download the app. This enables a connection with a Bluetooth receiver. How do we download the app? Flip to page 8 in your manual, and you'll find that there are 2 QR codes, one for Android and the other for iOS. For this demonstration, we use the Android version. After scanning the QR code, you should find yourself at the Gigo section of the Google Play Store. The app you need is called Gigo Smart Machines. If you use Android, you must run Android 4.4 or later. iOS devices must be running iOS 8.0 or later. Also, to avoid compatibility issues, your device must support Bluetooth V 4.0. Before introducing our sensors and planetary motors, we have to install batteries into Bluetooth receiver. After installing the 3 AA batteries, replace the cover. When you flip the receive over, you should be able to see a blue flashing light. That means the power is on. If you leave it to idle for a while by not touching it, then the blue light turned off by itself, showing the device has gone to sleep. Simply shake it to wake it, to make it switch on again. Now let's install some sensors. This is an ultrasound sensor. One eye sends out an ultrasound signal, and the other eye receives ultrasound signals. This means it can detect whether there's an object in front of it and how far away it is. It can even tell how far away something is at night. Look at this connector. You can see it is not a full circle. There's a small flat edge here. This is to stop the connector being inserted incorrectly, because there's also the same design on the pin side. When we plug it in the connectors, align directly first time, every time. Just a friendly reminder, your sensor must be inserted in the middle socket, and the left and right sockets are reserved for your planetary motors. Those are inserted the same way, with a connector and a pin. Now that is the most of the setup complete. If we want to remove this connector, then we can use the peg removal tool and it plugs in like this and comes out easily like this. After you've downloaded the app, you'll be able to see this icon on your device. Before clicking on it, please remember to enable Bluetooth on your device. First, it needs that to communicate with the receiver. So, after turning on Bluetooth, you can click the Gigo Smart Machine app. It'll take a second to start up. The welcome screen looks like this. There's a symbol that is always flashing in the upper left-hand corner. This is telling you that the Bluetooth is not connected yet, and you'll need to click it to start a connection. If it is connected successfully, you'll see a change in this flashing icon, where the flashing becomes a constant light and does not flash. Also, you'll hear the motor run for 1 second as the test. Great, this means the Bluetooth receiver and the device are successfully paired. Here you can see the left slider control. This controls the motor connected to the pin on the left when the battery is facing down. Now test the motor. Slide the slider up and the motor will spin clockwise. Slide it down and the motor will spin counterclockwise. It will spin in the opposite direction. The right slider functions the same way. It controls the right pin, and the motor can spin clockwise or counterclockwise. Now check the middle part. Can you see the circular ring that looks like a radar? This shows the distance of any obstacles in front of your sensor. Suppose it has no obstacle in front of it. This means the green circle will be large. If an obstacle comes into range and get closer, then the green circle will get smaller and smaller. Can you spot the difference between the original green circle and the one we just saw, where it became very small? Once again, if there are no obstacles, it becomes bigger. This is how it indicates the distance of obstacles or objects. This is all part of our remote control functionality. Now have a look at the programming mode. To enter programming mode, click the gear button in the upper right corner of the remote control mode. After clicking it, you will find 24 programs. Most of them are default programs for base models. Because you have 8 models here, it contains several default programs that look like this. Of course, there are also blank programs for experimentation, like Program 8, which is deliberately left empty. Try using the blank program to test the device. So how can we make a program? First, look at the gray column at the top. Click on the plus button, and 3 options appear from left to right, which are motors, nodes, and rest. Let's try something with motors. The blue gear shows motor 1, which you connected to the left pin. The red one is motor 2, connected to the right pin. If you think you might forget which is which, then you can use blue and red pens to make a small mark, like I have. Some people also use stickers to distinguish them. This way, when you are choosing motor 1 or 2, you won't get confused. Now we can see clearly which is which. This one has a value between +4 and -4. This number represents speed. Plus and minus is represent the spin direction. Now the left motor is spinning clockwise at full speed, and the right one is reversing at minimum speed. The speed values I use are -1, 4, and -1. This part also lets you set the duration of motor spin. I set this one to spin for 2 seconds. Now this program has all the information it needs, but how do we actually make it drum? To do this, press the trigger button on top. Here, you can see the loop checkbox. When the loop checkbox is checked, the program will run continuously. If you leave it unchecked, then it will stop after 1 iteration. Okay, for now, check the loop checkbox. So now motor I will be running at full speed. And at the same time, motor 2 is reversing at minimum speed. Also, the 2 motors are running in different directions. This concludes the introduction to motor programming. Okay, now let's look at sound. If you click the note button, you'll see do, re, mi, fa, sol, la, si. These are the tones you can generate to make an arrangement. Here you will also be able to set the duration of the sound. This is where you can arrange a song. Let's see if we can make it sing Twinkle Twinkle Little Star. The melody is do, do, sol, sol, la, la, sol, fa, fa, mi, mi, re, re, do. So the melody is quite simple, but we have to remember timing. So we'll make each tone last about 0.5 seconds. To make it more natural, set the last tone for 1 second. When you finish inputting the melody, tell the device to pause for 1 second. This is a chance to use the last program we have available, the stop program. As its name suggests, you can make a program stop for a few seconds. With a song, we want to make a program stop for 1 second after each round, so we put it in the program. Now we can continue the melody again afterwards. Now let's play it once. like this. If you practice with this and use a sound program a lot, and you or your child will be able to have fun composing. Next up, we can see the value of the ultrasonic sensor and where it can be used in programming mode. There is a white number in the upper left-hand corner that will tell you the sensor value. This is the current return value of the ultrasonic sensor. It represents the distance between the sensor and any obstacles. The device gives it readout in centimeters. Right now, there's nothing in front of my sensor, so the number reads around 100. If you use your hand as an obstacle in front of the sensor, then its value will drop, like this, to around 10. That means there's an obstacle approximately 10 cm away from the sensor. Now check the indicator line below. Did you see that the indicator line is divided into 3 areas by 2 orange markers? These are blue, green, and purple areas. These 3 areas represent threshold or cutoffs that can be used in coding. This means you can use the value of your sensor to decide which program will run according to the color segment in use. See here, where the blue area represents the range 0 to 30 cm. This means that when the sensor sees something in the 0 to 30 cm range, the program motor 1 spin clockwise speed +4 will run. But what about the range 30 to 50 cm? Let's make it play a fast sound from your phone that lasts for 2 seconds. Finally, what if the distance is in the range 50 to 100 cm? Now the program motor 2 reverse full speed will run. The program is all set up. Right now, you can see that motor 2 is spinning because the sensor distance exceeds 100 cm. The current distance is 50 to 100 cm. Now put your hand in front. The distance is 0 to 30 cm now, so motor 1 starts to spin. Now you can hear the fast sound because I just moved my hands to the distance of 30 to 50 cm so the phone plays a sound. This way, you can use the value of the sensor to decide which program will run. The value above the indicator line can also be adjusted, so the range doesn't have to be 30 to 50 cm. The markers can be moved to affect the ranges. For example, try and change it into 0 to 20 or 20 to 30. You can also increase the number of range markers. You just have to press the indicator button to the right of the delete button. After clicking, you can see that there is a new range marker on the right. Now we can slide it back again. Note that because there are 3 range markers, it has added a red area here. Try clicking the down arrow on the lower right. Now there's a new red segment here, and you can add another program. So within a distance of 0 to 100 cm, you can add up to 8 range markers, for a total of 9 segments. However, the range is restricted to 0 to 100 cm. Now, if you think your program is set up well, and you want to save it, select the disk button on the right. If your program is not what you wanted, and you want to revert to the last saved version, simply press the Revert to Save button. Next, if you want to see other programs, click the Storage Box button to the right of the Play button. This way, you can move to a different program directly. When you want to leave the programming mode, press the Door button. A window will pop up asking you if you are sure. After you hit the check mark, you can go back to remote control mode. After you finish with the trackball, you can use the remote control mode to control it. If both sliders are up, the trackball will move forward, and if both sliders are down, it will move backwards. If one slider is up and the other is down, it will spin around in circles, like it's dancing. Again, you can enter programming mode to choose the default program. The default program for the trackball is 17. You also see that most of the programs are related to music. Now, let's run it. First, it will sing a little song. Next, it will do some dance moves. This is the default trackball program. Thanks very much for joining me for this unboxing video for Gigo Z7412, the robotic smart machine track and treads. I'm Teacher Raccoon. See you next time. Bye.